Are P implies Q and its contrapositive, not P, implies not Q, logically equivalent? So to see if things are logically equivalent, we construct a truth table. Their column, as in the column for P implies Q, every entry in that column needs to be exactly the same as the entry in the column for not P implies not Q. So we need to kind of start with P, start with Q, and build up from there. So let's just go standard truth table stuff. So if we have P and Q, so we have for these two propositions 4 possibilities. There is P could be true and Q could also be true. P could be true and Q could be false. P could be false and Q could be true, or they could both be false. And this is the standard convention. If you ever sort of look up a truth table, there will always be these 4 in this order, right? So P and Q. So then I'm going to build up to my last 2 columns are going to be P implies Q and the negation of P implies the negation, the negation of Q implies the negation of P. So the 2 that I want. So if I now have negation of P and negation of Q, so if you just think about that logically, when P is true, the negation of P is false. It's just, so if P is true, not P is false. So basically you're just altering all of these. So false, false, true, true. Exactly the same for Q. When Q is true, the negation of Q, the not Q, is false. So when Q is false, the negation of Q is true, and false and true. It is worth being careful with these because they're so simple just to make a little mistake, and if you do it, it will really derail everything. So now we can start to do these things. So I want a P implies Q column. P implies Q. Right, so for P implies Q, remember, something like this, for one thing, implying something else, it can only be false when it's undeniably false, as in when this is true and this is false. That's the only time that can be shown to be false. So that happens here. So here P is true and Q is false. So that means this implication must be false here. But everywhere else it's got to be classed as true because it can't be classed as false. So when this is true and that's true, of course it's true. When P is false, there's no way P implies Q can ever be false if P is false in the first place. It's inconclusive, really. So this is true and true and true. So that is the column for P implies Q. So now let's do this negation statement, which is not Q. Remember, this is the contrapositive. So not Q implies not P. So I probably should have written these the other way around, but never mind. So we're looking here for the right implying the left. So because I've got my not Q written after my not P, this will only be false when the not Q is true and the not P is false. So does that happen? Well, not P is true here and not Q is false. So this implying this must be false here. And anywhere else, as if they're both true, then this has to be true. So that happens here. The negation of Q is true, and so is the negation of P, so it's true. And then if the negation of Q is true anywhere, then the negation of Q implying the negation of P will be true because it's inconclusive. So that happens here and here, so it's true and it's true. So now to see if these things are logically equivalent, we compare these 2 columns here, and you can see that they are identical. So that proves that, yes, P implies Q, and it's contrapositive. contrapositive. Not Q implies not P. They are logically equivalent because their truth table columns are identical.